So I'm really pleased to be here this week with Dr. Gbemi Oluleye, and I'm going to ask her to introduce herself. She's from Imperial, doing a lot of work in decarbonisation. But Gbemi, can I ask you just to tell the audience a little bit about, what you're doing and why we're in conversation?
All right, so I'm a research fellow at Imperial College and I'm based at the Center for Environmental Policy. My research expertise and experience is quite multidisciplinary and it lies at that interface of engineering, economics, and policy. So what do? I develop decision support frameworks to provide evidence or to decide, what combination of technologies, strategies, system, what combination of raw materials is necessary to decarbonize industrial energy system. Now, what made me interested in decarbonization? So a bit of a background. My interest in chemical engineering happened when I was 9. I visited an oil rig. I saw a beautiful picture. It shows
That normal for a 9-year-old? Why were you visiting an oil rig? That's
Now, it so
amazing.
happens. So I grew up in Nigeria. Oil was the mainstay of the economy. So if you wanted to go for like as a kid, if you wanted to go for a career meeting or whatever, it was the oil rig or an oil company because they had all these opportunities. So my parents grabbed them, sent me up there with my hard hat. It was just a day trip. And I saw this picture on the wall. It was the flow sheet of the plant and it captivated me for the entire trip. Now, my sister says she was captivated by the food. I was interested in that picture. And I said to the tour guide, that I wanted to be able to produce that picture. And he said, then you have to be a chemical engineer. I mean, if he said I had to be an artist, I would have struggled. So that's where my interest for chemical engineering started. Now, when I graduated, I worked in a design firm. And with the team, we produced several of those pictures for different plants. And afterwards, I was told, okay, we still need energy, to drive the reaction. So I came over to the UK for a master's, got interested in energy systems. And of course, I also got interested in decarbonization of energy systems. And so I knew that, okay, chemical engineering probably is not sufficient to answer the research questions in this area. So I started gaining experience and expertise in economics and in quantifying the impacts of policies. So that's why I'm here now, back into the industrial sector, because industrialization is necessary for development. So my goal is to see it happen in a sustainable and clean way.
So I found you, I think I'm trying to remember now, as either through an article or something about something you'd taken place. And the thing that grabbed my attention was partly that I'd wanted a different perspective on the podcast. So I had been trying to find someone from an academic background to bring something different. But it was also because that particular article had you talking about this issue of the time it's taking from from the innovation of a new technology through to real scalable commercialization. And as you and I discussed when we first made contact, the industrials that are in our audience, that's really one of the, top 3, I suppose, issues that will come up in conversation is, it's great. There are all of these startups out there. There are all of these new technologies. How does that help me? Because, I, as an industrial site or a collection of sites, we need things that are at scale.
So there are different stages in the development or in technology innovation. You have the research phase, you have the development phase, you have the demonstration phase, and then you have the deployment phase. Now, research development is usually supply push. So a researcher has an idea of a technology, and then they do some more research, they do some more development, and they have a demonstration phase where the technology is demonstrated, and deployment where it goes from supported commercial to full commercialization of the technology. Now, the time from research to deployment, 20 years, 30 years ago, the minimum time was 80 years and the maximum time was 130 years. But now we've seen it reduce to 20 to 70 years, which is the time from, research to the deployment of a technology. Now, this is, we quantify this in what we call technology readiness levels. So it goes from 1 to 9. 6 is for demonstration, and above 6, it means the technology is in the market. So what we've seen is is a lot of these technologies that can get industry to net zero carbon are not yet commercialized. Some of them have been demonstrated, but they've not reached that point of commercialization where they are competitive with the counterfactual or with the business as usual technology.
So if I can jump in there. So when you're, I know, again, very broad question, but there's a whole range of technologies. And I've been talking recently with Tüpraş, as an example, a refinery in Turkey, and they are demoing MOFOAir. I'm going to get this wrong. It's a type of the carbon capture technology.
Yes.
So companies like them that are testing demos involved in that kind of demonstration phase, what level of technology readiness is that? Is that 6? Is that?
That would be a 6 to 7, yes.
Currently, in a kind of, everyone loves to talk in decarbonisation about the business as usual scenario. So in a business as usual scenario, when would you anticipate, I know there's a range of technologies at a range of stages, but on average, when do you think, if we did nothing and changed nothing about this process, when are the kind of these newer CCUS or very new hydrogen applications or so forth, when are they, how long will it take to get them to a kind of commercial stage of application?
All right. So if we do nothing, if we allow the commercialization process be organic, whether it's based on supply push of the technology, it would take us 20 to 70 years to get the technologies to the market.
From now?
From now.
Oh, okay.
From now. And this is me speaking from what we've seen in the past. So I will take wind electricity. It took 43 years from research to deployment. And however, from demonstration to deployment, it took 18 years. And that's supposed to be fast because there were policies in place. In fact, the UK government is now in support of wind electricity. So we're going to see some more rapid adoption because of that statement, because of that policy environment. So if you take solar PV took 55 years from research to deployment. Now, after solar PV was demonstrated, it took about 30 years to get to full commercialization. A technology that has taken 5 years from deployment to, from demonstration to full commercialization is the combined cycle gas turbine. And why did it take 5 years? 2 reasons. It was, now, first of all, for the combined cycle gas turbine, it took 47 years from research to deployment, but it took 5 years to get to full commercialization. And that's because it was the gas climate in the UK. The UK was moving to natural gas. So the UK is the inventor of the CCGT. So there was a demand pull for this technology. The policy environment was right. Everyone wanted gases in their homes. Industry had to use natural gas. So it was 5 years. So there is something in not allowing the technology go through the organic process of commercialization. There's something about having the right demand pool, having the right policy environment to shorten that time.
So I suppose my assumption has been that there's something the industrials can do to push this faster, to make this cycle speed up. But it sounds more from what you're saying that really the onus is on the policy and environment. But is that right? Or is it just that's the angle you've mentioned so far? What would you say if you're in industry, if you're in policy, if you're an investor, what are the kind of the levers and the buttons that you could be pushing and pulling to help speed this up? Because obviously we don't have 20 years to just be at the point of deployment, so yeah, tell me a bit about that.
In the power sector, when electricity is a public utility, then the policies have a higher weighting in accelerating that transition or shortening that time. For the industrial sector, where it's mostly privately owned, I think it's a simultaneous innovation on the policy, in the aspects of policy, and also on what industrialists can do. So effective policies, whether in form of grants or mandates or incentives, can take us to demonstration. But after demonstration, I think this is where the industry needs to think of what to do. I'll give some recommendations on how to accelerate the space. Once it has been demonstrated, how can we, support to get to full commercialization? Because what we've seen in the current times is the size of the markets affects the diffusion of the technology, and that can reduce cost.
Okay, so on that point of the kind of how the scale of the market impacts speed of commercial applications, being ready. So just explain a little bit more about that. What does that mean? What opportunity does that offer for decarbonisation?
Okay, so I'll give a practical example of a project I worked with for the European Union hydrogen project. So the project was on increasing the adoption of fuel cells in a particular industrial sector in Europe, so in wastewater treatment plants. So it was focused on technology switch to fuel cells, which are more efficient, and also to fuel switch, so moving from natural gas or whatever fossil fuel is being used in that particular industrial sector to biogas. So we've seen two things here, technology switch and fuel switch. These are strategies to support decarbonization of industry. We identified about 6,800 plants that are suitable for this technology to be integrated in. Now, we picked a particular plant to demonstrate this technology. It was a large consortium, so the demonstration ran for 5 years. So the question, our part was to say, how can this technology get to the market, within 5 years or within 10 years? And for these 6,000 plants that were identified, today, the technology is not economic. So even if you were to advertise the technology to them, they'll probably not buy it because it is more expensive. It was 8 orders of magnitude more expensive than its competitor. Now, the demand, if this technology was competitive, the demand for the number of units would have been about 13,200. Now, based on the manufacturer's data, 13,200 is what the manufacturer needs to reduce costs to the point where the technology becomes competitive. Because based on the size of the market, they can improve their manufacturing processes, they can automate the process, they can benefit from economies of scale. But how do we find 13,200? Which is why, this is the time, this is what affects that time. So what did we do? We simulated all these plans. We went into the engineering model, said, okay, this is how we came up with the 13,200 number. And then we said, for a business as usual case, no one is going to buy this technology because it's expensive if we go by cost. We also released a survey to say, will you buy even if the cost is expensive? No one was interested. So what we did was to say, okay, there are policies to support the use of biogas. There are policies to support fuel cell integration in Europe. So for each of the countries in Europe, what are the policies that are available today? So we applied these policies and we discovered that out of all these policies in these countries, the demand will increase from 0 to 100 units. We still have to go to 13,200. However, with 100 units, we could get a 37% reduction in costs. But it's not sufficient to drive the market. We needed a 71% reduction in cost from what it is today for the technology to be competitive. So what else did we do? We simulated different cases. Okay, these are existing policies. What if the offering around the policies, the incentive increases to 1.5 times the value? It still wasn't sufficient to give us the cost reduction we needed to shorten the time to commercialization. So what we did was to say, what if we have a simultaneous innovation in policies and also that's the offering around the technology? So the business as usual business model is the plant owner pays upfront for the technology. So you incur the capital cost from year one. but this technology has a lifetime of 20 years. So we said to the technology manufacturer, is it not possible to offer a business model where the plant owner does not have to pay upfront? It's similar to the way we buy houses in your mortgage. And they were like, okay, so what's the impact of that? We estimated, we quantified the impact of that, and voila, we're able to achieve 71% reduction in cost today.
So that's fascinating, isn't it? That kind of combination of a policy suggestion or a policy reality with, the other party, the kind of the buyer, the industrial, having to commit to something that they are, perhaps still has some element of risk to it, and the technology vendor has to play a part in that too. So it's a sort of a much more kind of, to some extent, a more equitable distribution of the risk around that kind of technology. So if we sort of take that sort of example of a kind of a business model, a policy model, a kind of the customer's agreement to get involved, what else do you think, if you were making a recommendation for policy right now, and it's up to you, you can make this UK, you can make it European, you can make it global, I don't mind, a policy recommendation, an industrial recommendation, an investor recommendation, what do you think you would be trying to point to that could actually, start to accelerate even more the kind of the good work that's already happening?
So I'll make this recommendation within the context of the industrial sector and in the context of the UK. Now, for a policy recommendation, I would say a policymaker needs to be able to use all the tools they have. So mandates, incentives, constructive, destructive incentives. So a mandate, for example, for the industrial sector could be on energy efficiency. A mandate is also in form of a target, which they've already set. In terms of incentives, I would say deploy the use of both constructive and destructive. So a constructive incentive already in use in the UK, the Industrial Strategy Challenge Fund, the Clean Steel Fund. A destructive policy is in terms of a carbon tax or the EU emission trading scheme. Now, unfortunately, in the UK, the gap we've seen is a lot of these constructive policies only support the technology up until demonstration. There's still a gap in deployment. There's still a gap in getting the technology to a stage of full commercialization. And that's because the cost involved is large. It's not a trivial cost. Remember that industry is not a public kind of utility, it's privately owned. So the cost involved, it's going to be a lot to go to support from demonstration to deployment. However, the right policy environment in terms of mandate, in terms of targets, can also create the right investment environment and can help investors to bear the risks. Another recommendation on the policy side is for the power sector, we've seen a lot of direct impact of policy on technologies. So for example, for solar PV, there is a feed-in tariff. I think for the industrial sector, what might cause a change, or what I believe will cause a change, is if policymakers, incentivize industry to change their business models or to innovate their business models, because that will encourage investors to invest, and that will also encourage industries to drive the transition from demonstration to deployment. So if they have support to innovate business models, that will change things quicker.
And so an example of that might be, just, it doesn't have to be the biggest one, but just what kind of a business model shift might fall into that kind of realm of thinking?
So in the UK, the energy intensive industries are based in clusters, and the UK has taken a good initiative to decarbonize within clusters. So within the clusters, they usually share utilities, they share facilities. So a business model that will work in clusters is something we've worked on and is something we've quantified. Is, for example, looking at industrial decarbonization as a service. Industrial, that's the first one. The second one is industrial low carbon technology leasing. And the third one is industrial decarbonization system orchestrator. So I'll explain the industrial decarbonization system orchestrator. So instead of a situation where all the plants or all the industrial sites in a cluster decarbonize separately, it's possible to have an orchestrator who offers them decarbonization, and they have to pay an annual fee for it. So this orchestrator will bear the initial cost with the support of the government. So this is a business model policies can support. And then if I own a plant within that cluster, I only pay them for taking away my CO2. So CO2 is now seen, for example, as a waste. So I was talking to a waste an effluent plant owner, because this is how they do with the effluents. They gather all the effluents and an orchestrator takes care of it and they pay. So if we see decarbonization that way, that means the risks, the cost will be shared. Now, if there is an incentive to support this orchestrator, then it can happen quicker. It's not, we don't have it at the moment. We don't have an industrial decarbonization system orchestrator. People are hoping that the UK government will build the CO2 pipelines or build the hydrogen plants. But if we have an orchestrator to coordinate that process on the cluster, it could be a privately owned company or a publicly owned or government owned company that will shorten the time to commercialization of industrial decarbonization systems.
Okay, so that's really interesting. Yeah, decarbonisation as a service, I know it's sort of starting to come up as a little flash phrase in various news. But am I right? There's no one yet that actually has an offering of that, do they?
No, not in the UK. So, I think that's because the talk of industrial decarbonization and in the past, industry was considered as a hard to abate sector. So the focus was on electricity. Now, last year, the focus came to industry, and that's because of the net zero carbon targets. So even the clusters are just beginning to design their pathways. So I think, yes, that it hasn't happened because of it just started last year. I mean, the target was set in 2019, but I think it's something that industry is already discussing, what business model can work for us collectively. I'm saying a way to hasten that discussion or a way to support that discussion is for policymakers to think about incentives or offerings to make them innovate their business models quickly. Now, this is particularly important for industry because most of these in energy intensive sectors don't sell their products directly to consumers. So people who sell products, the particular sector, the meat sector who sell products directly to consumers, there is a market pull on them for clean products. But when you don't sell your product directly to consumers, there is a disadvantage in the fact that those sectors do not innovate their business models as quickly as the sectors who sell directly to consumers. So I'll take the fashion industry, garment production, where products are sold directly to consumers. They have had to innovate their business models in the past 5 years. So, for example, we have the Armadio Ved business model, which originated from Italy, which is about clothing exchange, especially for infants who outgrow their clothes very quickly. So that was designed to support a circular economy. And then we look at the electric vehicle industry, where you and I can buy electric vehicles. They've had to innovate their business model. So now you have e-mobility as a service, again, just to create that demand to drive down costs. You have the Schengen quick charging business model in China, which is the electric vehicle charging service provided by a third party. And even in the power sector, where electricity is sold directly to you and I, we can demand for clean electricity. So we've seen new business models like virtual power plants, local aggregator archetype, and we've seen the municipal energy service company. So, but for this particular industrial sector where products are not sold directly to consumers, I think they need support to transition or to innovate their business models. This is what will keep them competitive. So this is my advice for industry. Innovating your business models will make sure you maintain your competition, because the UK has stringent rules to decarbonize, but the rest of the world might not have, and they trade products globally. A way to remain in competition is to innovate business models to make sure that we see either industrial decarbonization as a service, or we have a system orchestrator for industrial decarbonization.
Okay. So if I kind of come back then, so that was kind of recommendation number one, was let's see constructive incentive that really gets to the root of supporting industry with that shift to new business models. So if you were going to make a recommendation to, well, it might not be a recommendation, well, your thought of how can investors play a part in this? So that's what policy can do. They can enable that. How, if you were kind of designing the Gbemi system of accelerated decarbonisation, what would you be recommending investors do, or how they look at this?
I think investors can also support new business models or create I'll call it an investment climate that supports technologies that can achieve a very radical reduction in CO2 emissions. So I would take, for example, switching to hydrogen, production of hydrogen. I would say they could offer loans at very low interest rates to support that first phase of deployments. Because what you want to do is to get to a point where there's a market pool, there is a demand that can drive down costs. So investors can support that phase either through the business models of the sector, or of a plant, of an industrial site, of a cluster, or through offering loans with low interest rate, or through direct investment into demonstration or deployment of technologies, because that will help to offset the capital cost of the technology. I think, to be honest, I see a positive view about decarbonization of industry, because globally, whether in the US or Europe or even in the UK or China, a lot of people are talking about it. A lot of industries are interested in it. I think this is what we need to create a market pool. But it's about all the actors, both the industry interested, the technology manufacturers, the government, the investors, all the actors playing their part simultaneously. It's more like we need like a system of systems orchestrator to say everybody needs to play their part simultaneously. And this is how we can create a market pool to shorten that time and to drive down costs quicker.
What's the role that Imperial and other academic organizations around the world, what do you see as the role for those institutions in decarbonisation, and how, what needs to happen for that to be a real kind of effective relationship with industry and with the issue of decarbonisation?
Yeah, I must say I would tell the role, but I must applaud the research institution, because most of them have been playing this role for years. They've just been waiting for the right target or the right climate. So research, Imperial, other universities have played roles on the research side, on the development side, on the demonstration side, and on the deployment side. So for the research side, we've seen different technologies being invented, being researched, being at the universities to bring about different levels of CO2 reduction. We've also seen a lot of research developing methods, or I'll say methods to design pathways to decarbonize industry. And most of these methods take technologies that, have just been lab tested, or technologies that have been demonstrated to show how to achieve net zero carbon. So we've seen that happens at Imperial, and that has been happening for a while. So that's some thought going into there. So we have very basic research in development of technology, but we also have applied research in the demonstration of a technology. So my research falls under the applied phase. So we take these technologies that have been tested in the lab, that, their chemistry, the physics around them have been decided. We take that, simulate them in a software, and see how they can be deployed or how they can be demonstrated and then deployed.
Just in the same way that industry can't be siloed, so the academic institutions, in whether it's in the kind of pure research or in their applied project work, that can't be siloed either. What it's going to take is actually all of us in a system together, me as consumer, you as academic, industry as industry, policy make, that everybody has to play a part in order to accelerate. Otherwise, it's just all of us shouting at each other in our own little silo, isn't it?
Yes. And we all think we know what the solution is, but when we talk to each other, we see, there are so many challenges to achieving that particular solution. I mean, one thing about Imperial College that I appreciate or I like is we're very much focused about solving global challenges, whether related to climate change or whether related to pandemics. And what we've seen is the development of multidisciplinary centers, which takes all of us out of our various silos into, I'll say, although another silo, but it's better because it now gives us a different perspective, like a whole system perspective towards achieving, for instance, decarbonization of industry. Now, you can imagine what will happen if we go a step further to create a bigger silo to interact with industry, interact with policymakers, interact with all the actors. So if we come up with, that's a pathway to decarbonize industry, they can say, we've tried that before, it didn't work. Or the technologists can say, okay, we know what to do to drive down the cost if we know the market size. So that way, everything happening simultaneously will get to shorten the time to adoption of these technologies, and we'll get to shorten the time to commercialization. And I think this is probably the only way, one of the ways, I think it's the only way because it's my recommendation, we can achieve net zero carbon by 2050, because the technologies are there, but the adoption today is zero. And that's because they are not competitive.
Okay. Well, Gbemi, I knew it would be a pleasure talking to you. Thank you so much for agreeing to step into my little podcast world. And yes, to anyone that's listening, we'll put some links in the podcast notes and some links to Gbemi's work there, and any articles that she would like to promote, so you can take a little bit more about what she's doing. And yes, thanks very much.
Thank you, Alex. Thanks for your time.